Hi everyone, this is Sunny Kumar from IIT BHU and welcome to my channel Code with Sunny. And today I am going to discuss the problem Bob and Consulting Sessions of March Circuits 2021 of Hackerearth. Okay, so let's discuss the problem now. In this problem, basically, this basically a mathematical problem of you can say this requires a basic prerequisite knowledge of combinatorics. And okay, so let's first read out the problem. Okay, so there is a person Bob, and he's going to arrange the meetings during his ceremony. And Bob that okay, the school told Bob that each student should meet the counselor at least once. Note that the student should meet the counselor at least once times. Okay, and he should not send any group to the meeting twice. Okay, it means that we have to find out the distinct combinations. And now Bob loves combinatorics so that he wants to set the arrangements, but the order is not important to him. Okay, one arrangement exists. Okay, so Bob wants to solve this problem to check his answers. Okay, so basically we have been given the n, and we need to find what are the total number of distinct combinations, or you can say the distinct arrangements of the persons, because there will be n persons, and we need to find the total number of distinct combinations, so that at each time we are going to send a pair of students. Okay, so for a particular combination we have some pair of students, and such that there will be all n students involved in that combination, and the total and the combination should be distinct, and as simple as that. Okay, so let's read out the constraints. It would be like 10 power 5. And okay, so for n equal to 3, you can see AB and AC. Here you can see all the three participants are involved, and every participant meets the counselor at least once times, and this is distinct with this one and this one and this one. Okay, you can see every participant is involved at least once time, and the combinations is going to be distinct. Okay, yani okay, so means AB equals BA. It is simple. That's why we are not including like BA and AC, because AB equals BA. We are going to consider the distinct arrangements, because AB is simply as BS, considering a pair like AB first person second person is equivalent to second person first person. Okay, so this doesn't matter. So let's move further to analyze this problem in best efficient way. What should be the best solution to find this number of distinct arrangements? Okay, so let's move further. Okay, I've taken the example like okay, n is given as 5. You can see there will be 5 persons, and 5 persons A B C D E. So what should be the total number of distinct pairs that we can form? It is simply binomial of n, that is binomial NC2, and it would come into like n into n minus 1 upon 2. Here it is n is 5, so it will come out to be 10. That is total number of 10 pairs we can easily find. Now okay, so what so 10 pairs is 10 pairs are present here, and we need to find out the number of distinct combinations such that every person is involved in that combination for a particular combination at least once. That is, we can have we can have a solution like AB and okay, CD, and we can have a solution like D. Okay, so this is a particular solution. Okay, so this is a particular solution. Why this is the correct particular solution? You can see A is involved at least once times, B is involved at least once, C is involved at least once, D is involved two times, good, and E is involved one times. And this is a particular solution, and this is valid. And so what are the invalid solutions? Let's write down over there also. Okay, so the invalid solutions will be like when I am considering only AB, only AB. This is not a valid solution. Where are C and D and E also? C, D and E are not involved. So this is not a valid solution, because you can see, okay, so each student should meet the counselor at least once. Okay, so this is not a valid solution. Also, you can also see like these are the solutions also not valid, like AB and like D and C is not involved. This is not a valid solution. So what I'm going to do is we need to find total number of solutions, that is total number of distinct combinations possible for these arrangements. So how we are going to do that? Okay, so let me first erase this stuff. Okay, so let me do this. Okay, okay, so okay, so this is the total number of pairs. You can find it out. Okay, so what is the total number of combinations possible for these 10 pairs? It would be simply 2 power 10. That is around 1024. 2 power, okay, 5. Okay, so 1024. Okay, now we need to subtract the total number of pairs that are not possible. So what are the total number of pairs that are not possible? That is, using that pairs, we are not going to get the correct answer, or that is, we are not going to satisfy the question requirements. That is, at least one student should be involved in that combination. Okay, so these are for A B C D entire, that is, we are considering A B C D entire A B C D. And what about when we consider only A, B, C and D? That is, we are, let's suppose we are just eliminating E, and we are going to find out the total number of combinations due to only A B C D. So that combinations need to be subtracted because E is not involved. So if E is not involved, the total number of combinations possible due to this A, B and C and D, this will not be valid. So we need to subtract this. Okay. So let me write down in general case. So it would be like, this is A, B, C, D. So I am going to choose any n minus 1 elements. So because I've chosen like A B C D, and it may be like B C D E, or it may be like A C D and E, and that is I'm eliminating B. We can choose any 4 elements. Okay, so in general I can write any n c n minus 1, and if I'm going to choose this one, so what should be like total number of combinations possible for this one? Total number of combinations possible for this one into is I into I minus 1 upon 2. And what is I over here? I is simply n minus 1. So we can write in more general case, that is, you can see nci into 2 power I into I minus 1 upon 2, and we need to subtract this one. So let me write down general term along with, that is, if we generalize this case, our answer should be like, just include the total number of pairs, that is ncn into 2 power, let me write it as I. Okay, so let me erase this first. Okay, okay, so I'm going to do that. So let me write I nci and 2 power I into I minus 1 upon 2. And what about, we need to subtract this amount, minus nci into 2 power, you can say I into I minus 1 upon 2. Here I am going to write that I is n, and here I am going to write as I as n minus 1. And now I selected these 4 quantities, that is, these any 4 we can select, like ABCD, or you can say BCDE, or you can say ACDE. We can select any 4. Okay, so if I am going to select any 4, these are the total number of combination that we need to subtract. And what about when we select any 3? Like, let's say I am going to choose A, C and E. So if I am going to select A, C and E, then it would be like, we can select any 3. Okay, so let's select any 3, or you can see we are going to select n minus 2, that is any 3 elements. And what should be the total number of combinations? 2 power I into I minus 1 upon 2, simply, where I is nothing but n minus 2. And okay, so we what we have to do with this amount? We need to subtract this amount from the actual answer that we are going to hold, or we need to add this amount with the answers. So now comes the major role. Let's consider the rule of principle of inclusion and exclusion. So what does principle of inclusion and exclusion says? It basically says that if you are going to find out total number of combinations or the total number of ways for finding out the total number of arrangements for a given set of elements, and if the elements are going to be repeated by selecting like you can say, okay, so I'm going to write a general case. I have selected 4 elements, then I've selected 3 elements. And now here you can see I've selected A, C and E. What about when we selected A, B and C? You can see these elements are going to overlap with these elements. And similarly also, if in the above I have selected A, B, C, D and E also, so these are going to overlap with each other. So how we are going to make my that is how we are going to do smart work. That is we are going to just count the total number of distinct ways such that we are not going to add up any extra answers, and we are not going to subtract any extra answers, so that we can get the answers the lesser than the required answers. Okay, so in that case we need to do a very smart work, that is just apply the principle of inclusion and exclusion. That is if we are going to subtract this amount, then just add this amount to our answers, that is our current answers that we are going to possess. Okay, so just our first term will be added, second term will be subtracted, and third term will be added, and similarly so on. Okay, where I is going to start from n. Okay, because I need to first select the all number of that is first we need to select the total number of ways first. Okay, then we are going to subtract, then we are going to add, then we are going to subtract, then we are going to add, where I is going to vary from n to 0. Okay, because there will be n people, and finally it goes up to 0. Okay, so why we are going to do that, like signs are going to alternate? Because just I am going to apply principle of inclusion and exclusion. Why I am going to do that? Because we have observed that these solutions, that is picking any three and picking any four, have the elements like overlapping elements like okay, so in more brief I can write let's say I have chosen like A, B, C and D, and in the next case I am going to choose like B, C and D. Note that I am going to choose any n minus 2. So it might be like A, B, C, D. So you can see these solutions are going to overlap, because in this case total number of combinations would be like 2 power 4 into 3 upon 2, that is 2 power 6. You can easily see, and in this combination total number of would be like 2 power 3, 8, and you can see in this case also there are some combinations that are also available in this one. So we need to be careful, such that we need to count those number of combinations, those number of pairs that are going to be distinct. That is, we are going to count that only one time, not more than one time. So just apply principle of inclusion and exclusion and get the answers. So overall, what should be our general term to find out the answers? What should be our general term? So let's write down the general term first. Okay, so I'm going to write okay, so first erase this stuff. Okay, just select this one and erase. Okay, so let me write the general term. Our general term would be like sigma, and I is going to start from n, and I is going up to 0. That is, I'm going from n to 0. That is, you can see n to 0, n to n minus 1, n to it goes up to like that. Okay, up to 0. Okay, so our general term would be like minus 1 power minus 1 power n mod 2. Okay, so let me first okay, so I need to be very much more specific over here. So I'm going to write down here like okay, n mod 2 n mod 2 equals I mod 2. So this is my minus 1 to the power this one, multiplied by choose any I elements, and what should be the total number of combinations for these I elements, that is 2 power IC2. choose any two, because there will be four elements, let's say I elements. So what should be the total number of distinct pairs? Total number of distinct pairs would be IC2, and what should be the total number of combinations possible for IC2 pairs? It would be 2 power IC2 simply, and we need to select any I elements from the n elements. Okay, so let me generalize this case by writing some elements. So I am going to start from n. So if I am going to start from n, you can see I is going to be n, and this equation, this relation will satisfy. So it would be like okay, first term will be like minus 1 to the power 0. Okay, so minus 1 to the power 0, it would be simply like 1. So it would be like ncn, and it would be like 2 power nc2. So this term is basically choosing my entire answers first, then choose my, then subtract any n minus 1 elements, combinations due to n minus 1 elements. It would be like 2 power n minus 1 c2, and just add up the remaining n minus 2 elements, 2 power n minus 2 c2, and it goes up to like it goes up to 0 simply. Okay, so this is our answer, actual answer for this problem. Okay, so let's move further to the coding part. Okay, so one thing that I have forgotten to mention here over that is I need to denote, I need to write one thing, that is n goes up to 10 power 5. So we need to calculate this, you can see binomial, that is NCR, very much efficiently, and also we need to calculate 2 power n uh, modulus this prime number, that is 10 power 9 plus 7 efficiently. So how I am going to do that? Just use binary exponentiation, and if you are unaware about the binary exponentiation, check the description section of the video. You will find that the very best video for ever. Okay, so let's find it out. Let's code it out. Okay. So okay, so here you have a binary power function. So if you are unaware about this, again I am going to say that just check it out the in the description section of the video. Okay, so here I have an inverse function to calculate the inverse of a number, modulus a prime number. Here I have an NCR function. You can see if R is n or R is 0, return 1. Otherwise, if n is less than R, return 1. Here I have returned 1, and here if n is less than R, return 0. And you can see numerator would be n factorial, denominator will be r factorial into n minus r, and we need to take modulus because sometimes integer may overflow, and for denominator just have taken inverse and then multiplied with the numerator to calculate the NCR. Okay, here I have a globally defined factorial which would be like maximum it goes up to 10 power 5, and in the beginning I have taken just for 1 up to capital N the factorial values modulus. Okay, modulus with I into factor of I minus 1 modulus. Okay, simply now just start from the n and goes up to and go up to 0, and what should be a current answer? It should be like NCR of n comma I, and it should be like binary power that will calculate in log of n time. That is very much efficient. Okay, so if you are unaware about that, then do find it out. Okay, how we are going to calculate the power efficiently. Okay, so it would be like 2 power I into I minus 1 upon 2 modulus this one, and if this is going to true, that is I mod 2 is exactly equal to n mod 2, just you are going to do that. Okay, what I'm going to do that, if I mod 2 is exactly equal to n mod 2, just we have a plus sign over here, otherwise we have a minus sign over here. Okay, so else, or I'm going to just subtract this, otherwise I'm going to add this if it is exactly equal to n mod 2. Finally print the answer. Let's submit this code and check it out if this is going to work fine or not. Okay, so let's wait over here. Okay, accepted, accepted. Okay, it's taking time. Wow, accepted again. Okay, 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 it's accepted. So if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.